Good afternoon and welcome to Johnson Space Center. We're here with the Expedition 57 crew members who have been busy getting ready for their launch coming up on June 6th. They have been hard at work at training, but they are taking a little bit of time out to talk with us today. We're going to introduce them and let them talk a little bit about themselves, and then we'll be taking questions both from our audience here in the room, online, and if you're watching at home, you can also send in your questions via social media using the hashtag AskNASA. So to do quick introductions, right here to my right is Serena Auñón-Chancellor. She is a Colorado native who came to NASA as a flight surgeon and was selected as an astronaut in 2009. This is going to be her first trip to the International Space Station. On her right, we have Sergei Prokopyev from the Russian space agency, Roscosmos. Sergey is a pilot with more than 900 hours in the cockpit and 140 parachute jumps under his belt. This is also going to be his first flight, and it will be he will be the Soyuz commander for the mission. And then on the end here we have Alexander Gerst, who will be the commander of Expedition 57. He is an ESA, or European Space Agency astronaut from Germany with a background in geophysics. And this will be his second trip to the space station. He was part of the Expedition 4041 crew as well. Now we're going to let you talk a little bit to them. We'll start with letting Serena introduce herself and tell us a little bit more.
Sure. Actually, thanks, Brandy, for the introduction, and thanks to everyone who's here today. It's certainly very exciting. It's kind of a nice break from training. We've been training very hard for the last few months together as a crew, both in Star City and then out here as well. Making sure we're ready to fly to station in June. And it's been great also because in the past few weeks we've begun to get a lot of briefings on the science that's going to take place on board, and so we've been getting excited about that and learning what we'll be taking part in. And I know that slowly that's a process that fine-tunes itself as we get closer and closer to flight. It's going to be a very busy time on orbit, certainly with lots of visiting vehicles as well. So I'm looking forward to it.
Thanks. Sergey?
Mm-hmm. Okay, good afternoon, everyone. I'm glad to see you here. For me, this is a great honor to be here and representative Russian Federation in NASA. And of course, we had a long time preparation for this event. We expecting our flight very well, and I think everything will be good, and we tried to perform all tasks, all experiments, programs in our flight, and to spend a great time in ISS.
All right, hope so. And Alex?
Thanks for the introduction. Yeah, I'm ESA astronaut, as you mentioned. Alexander Gerst is my name. I come from Germany, so we say I'm a European with German nationality. And you're right, Brandy, we did spend, I think, about 166 days in space on expeditions 40 and 41. I did a lot of science there. And right now preparing for our next expeditions, 56, 57. As Serena already pointed out, we're getting a lot of science briefings, which is great because we will have roughly about 300 experiments on the space station on our mission. So that's a great number. Also, a lot of them from the European Space Agency. I read there's about 90. And a lot of German ones too. I think the German Space Agency sort of collected quite a few experiments for our mission, so I'm excited to do that. You already saw what great crew we have. A very successful training so far, and also fun, not only in training, but also good friends of mine. We know each other already for quite some time. So I'm very lucky to have such a great crew to fly into space, and looking forward to that. Oh. And I think we're looking forward to your questions.
Well, next. And I think you both mentioned science, and just to give everybody a heads up, we have a lot of scientists here with us in the room, a mix of reporters and scientists, in part because Serena is particularly interested in some of the human research that is going to be going on the crew members here. So we may have some science questions sprinkled in with the others. But we're going to start with questions here in the room, and if you will raise your hand, let us know that you have a question, and then be sure and tell us your name and affiliation when we call on you. We'll start here with Eric.
Hi. Eric Berger with Ars Technica. Thanks very much for doing this. Serena, can you talk about when you found out about this opportunity and whether there are any circumstances whether you're expected to do an EVA?
About whether I was expected to do an EVA? All I can tell you is that when I was told that I'd be moving into the slot, that schedule would be worked out by the office. We're all trained equally within the office to perform EVA, robotics, science experiments. So none of that training changed from my standpoint. And so luckily it was a smooth transition with this new crew. And luckily, you know, you're training all along. And so the transition, again, like I said, was smooth, and went to Russia in January as planned. I'd continue training in the Soyuz spacecraft, many successful sims, and then back here in Houston to get ready and specifically prep for science.
Okay. Can you say when you were told you were going to have the opportunity to go with this crew?
I'd have to go back and look the exact date for sure, but I'll leave that to my management. I can talk with you about that later if you like.
Mark?
Mark Carreau for Aviation Week, and mine's for Dr. Serena Auñón-Chancellor.
It's really hard to hear you. Would you speak up a little bit, sir?
Yes, Mark Carreau from Aviation Week, and my question's for Dr. Serena Auñón-Chancellor, sorry.
It's all right, it's long.
You know, this is a big year for commercial crew, at least as it looks right now, and I wonder if there's some milestones, some activities that you might highlight that could or will take place during your session that that you think are particularly significant in helping that come about in the coming months.
Certainly, they train us way ahead of time, and on the books right now there are demo flights scheduled, and it'd be fantastic if when we got on the station that they were either there waiting for us or they came up while we were there. But all I can say is that the training that we do, we plan way out so that every crew's prepared to handle almost any vehicle that comes up, whether it's from SpaceX or Boeing.
Okay, it looks like we have one here in the back.
Ryan Korsgaard from KPRC here in Houston. I know there are experiments obviously ongoing here at Johnson talking about how crews interact. How do the three of you interact? Because given the crew has been together a relatively short amount of time, given your assignment.
So, relatively short amount of time from the crew assignment, but I've known these guys for a very long time. Alex and I were selected in the same class. And so even from the beginning when I started training in Russia, I'd also met Sergei. So for us, in all honesty, this is like one big family. So it was not uncomfortable at all. It was extremely smooth. And in all honesty, I feel like I've been working with these guys forever. So it's been very easy. You know, the training itself, we train both on the Russian side of the house, and training in the Soyuz spacecraft is a whole different type of training from onboard U.S. spacecraft systems and even the science. But it's been easy, and we've been getting along great, and our families have gotten together several times, so it's been a lot of fun.
All right, let's go over here.
Hi, Ed Mayberry with KUHF Radio. Question for Alex and then also for Sergey. Alex, your second time up, you have some free time when you're up there. What do you want to do this time that you didn't get to do last time?
Yeah, you're right. On the space station, we have a pretty tough work day. I mean, we work roughly about 12 hours a day if you add it all up. So in the evenings, the free time that we have is pretty slim, so about an hour a day per person. So you can spend that looking out the window. I mean, this is one of the things that everybody does, at least half that time, right? But then there's also administration work. You got to write some emails, and also, of course, you want to talk to your family. So this is something that I will certainly do in my free time. Then on the weekends, we do have a little bit more time. I spent that in my last mission trying to do little educational experiments that we got sent up by students and school children. That was a lot of fun, especially since I didn't know how they would turn out in the end. Some of them were amazing in terms of even the results that we got. Like we did some soap bubble experiments that we thought was just a game at the beginning, and then we actually realized that there's some process that we haven't completely understood in the stability of soap films or thin liquid films. So maybe there's a real scientific experiment growing out of that. And inspired by these sorts of little things that I did on the side, We have asked again school children and also students, university students, to design experiments to bring up that I might or might not get to do. It really depends on how much time I can spare. And looking forward to these. I mean, some of them are still a secret, so we're going to reveal them when they're up on station. Some of them I don't even know yet themselves if they're going to work, because we cannot upload additional materials for them, so we have to work with the station materials that we have. So it's an experiment also for me with an open outcome, so I'm looking forward to these.
That actually leads pretty well into one of the questions we're getting on social media, Alex. Claire on Twitter is asking on behalf of 9-year-old Chloe what your favorite science experiment is going to be and why.
Oh, yes, I get that a lot. But with 300 science experiments, to pick out one favorite, that would be really unfair. It would be a little bit like asking, who do you like better, mom or dad? Like, you cannot answer that question. So I know what sort of groups of experiments I really like, and those are the ones where it's very, very clear that they benefit us down here on Earth in a very direct way. And some of them are, for example, the medical type experiments, the human science, human research that we do on ourselves, like we give blood that will investigate it to check for markers that we can use for treating bone diseases, for example, osteoporosis. We have one experiment that I really like. They look at my brain structure before and after the flight. At first, I'm glad that they found something in the beginning there, and then they're going to look at detailed changes during the flight, because when we're up there in the space station, it's a little bit like what people suffer after having a stroke, which is a certain region in the brain not working properly anymore. For us up there in space, that's the sense of like balance, right? So our orthostatic senses are not completely working anymore. The brain has to compensate that. So how does it do that? How does it not lose orientation in space? It switches over to the visual sense. And that switch over is very similar to what people experience when they have a stroke, when they sometimes have to relearn to walk, to speak, all those things. The processes are similar, and we hope to study them by studying those changes that we have on the space station and then coming back. For us, luckily, they're reversible, but we hope that we can use that to develop treatments for people on Earth. And there's quite a few of these experiments that directly lead to new technologies. Like, for example, on my last flight, we installed a furnace to look at alloys, to investigate them, things that we cannot investigate on Earth, on given alloys or on alloys that we are looking for new materials. So in the future, when we have the data from the space station, we can produce new alloys in the computer, we can calculate them, but for that, we need the space station data. We need to fill that gap, and that's data that we can only get in space, because what we do in that furnace is we have a little bit of molten metal float freely for several minutes, several hours, and we investigate it without it touching in the molten state, without it touching any vessel around it. And if you think about it, you cannot do that on Earth. And we need that data to produce alloys on Earth in the future for new cars, for new engines, plane engines, aircraft engines have benefited from that research. And we do actually have one of the new Airbus planes that come out that has an engine in there with blades that are only half as heavy for the same strength that came out of this type of material research in microgravity. So we're benefiting from that directly down here on Earth by saving fuel. I think they save 15% of fuel, and they're not as noisy. So that's the sort of research that I sort of like most, because it directly leads to an improvement down here on Earth. But having said that, I think most of those 300 experiments will eventually lead to something like that, but on some of them it's just obvious because it goes in a straight line, and those are a lot of fun to work with. And as a last point, me being a scientist also, I like the ones where I can get my hands in there. Some experiments we only have to switch on and off and repair if something goes wrong. That's why we're there to make sure that if something goes wrong, we can repair them. But a lot of experiments, and those are in general the ones I like even more, is the ones where I can get my hand in the glove box or work. And Serena and Sergey are the same. I know that they like to tinker with things and like to put our scientific intuition in those experiments and make the experiments better. and deliver more data to Earth. Sorry for the long answer, but I think that's a big question because just saying, picking out one would not do justice to that science complement that we have.
That makes sense. Okay, let's go back here.
Hi, this is Mike Stenger from the JSC Cardiovascular and Vision Laboratory. This question is for Serena. We know that you're participating in many of the HRP-funded experiments, which is awesome. Thank you. I'm wondering if you have any physiology-related questions that you're interested in pursuing that we're not already investigating as a part of an HRP-funded experiment.
So interestingly, I think the first question I'm interested in pursuing is what it's going to be like on a personal basis the very first few days. You hear all these stories about how people feel, the fluid shift they feel in their body, everything on those first few days of flight. And so the first kind of big experiment is almost my own case study where I look at myself and see how I react and maybe compare that with those of my colleagues. It's certainly hard to pick an organ system. I'm still amazed at all we do not know. And you know, as evidenced by some of the ocular changes we picked up on really not that long ago, we didn't know they even existed. And then when they began to appear, we thought, well, how long have we been missing this? You know, what other things could we see physiology-wise that maybe we just haven't picked up on? Could be hidden deep down. You know, I think the body does, I think we don't give the body enough credit for how well it does with very low-level chronic insults. And what I mean by that is how well the body does with adapting to low-level radiation. Levels of carbon dioxide that are maybe a little higher on station than they are on Earth, a change in nutrition, microgravity itself. The body does a fantastic job at adapting, but you still see markers of that. So what markers are we missing? You know, and so I think there's so many things that I think are going to pop out even in the next 10 to 15 years, certainly as we're on station for the next 7 or 8 and begin to move beyond that. Once we even change the environment and go beyond low Earth orbit, how does that change some of the markers that we see in the body? So it's a good question. Thank you.
Okay, looks like we have one over here.
This question for Serena. Thank you. That's just a lead into my question was, you know, what don't we know about spaceflight on the human body? And you're participating in the repository study, and we're going to be collecting samples from you, but we're not going to analyze them because we're going to save them for answering future questions. So as a medical doctor, what do you think for exploration would be the most important things to protect as far as human systems go?
Yeah, it's fun. So again, certainly there's not one organ system you can ignore. I think some of the other things I think about as a physician, things that are, so when I treat my patients here on the ground, there are things I don't ever worry about. Quality of a pharmaceutical, you know, any sort of medication I give my patient, diagnostic equipment, things like that. And so as we go and proceed towards exploration, how do we handle some of those questions to enable protection of the human? I think, you know, even in practicing medicine for 15 to 20 years as I have, I look at treatment courses or ways we used to monitor a disease 15 years ago as compared to now, and it's changed dramatically. The markers we look at in the blood and the urine, things we used to think were important really aren't that important, and now we're paying attention to others. I think the exact same thing will happen as we continue out towards exploration. And a lot of that's going to be, you know, almost looking at it more in a preventive sense, where every individual is unique, and we may need to protect astronaut A a little differently than astronaut B, just based on not only their genetic makeup, their anatomic makeup, but how they react to certain things. So.
Okay, back in the back.
See, we're in good hands.
Lots of blood draws.
Scott Smith with the Nutritional Biochemistry Lab here at JSC. Serena, you mentioned the ocular changes that have occurred in some astronauts. To date, as you know, the cases have all been males. Do you think that's just a coincidence, or do you think we haven't flown enough females yet?
I'd love to say I think we have an advantage. But, you know, I think it's a combination of different things. Certainly, like with any good study, you need statistical significance and a good number of subjects. So I think until we fly more women, you know, varying ages and everything, then I think we'll get a little bit better answer to that question. I almost look more towards each individual. And it's funny, every time one of my colleagues goes on orbit, I take a look at how they look on orbit, because some of my friends, you see that massive fluid shift, and they just look so different than they do on the ground. Others, it's barely detectable, and they're both women. And so you wonder, why is that? Is that because their body is a little bit better able to adapt towards that sort of fluid shift for whatever reason, genetic, anatomic, not sure. you know, some folks, Scott, as you know, we see those changes in the eye, but that person doesn't feel those changes, so you don't see any of that clinical manifestation. And so it's going to be really interesting to see how we progress with this to try and maybe tease out who's more prone to it, or is there anything we can do on the ground to help prevent it a little bit better, whether that means we make sure everybody has an ideal blood pressure, ideal biomarkers, risk factors prior to flight. I'm not sure, but it's I still kind of try and work those things out in my mind, and I think to myself, what am I going to be like once I get up there? Am I going to be someone that really shifts, or maybe it evens out in a few days and you can't even tell? So it's going to be interesting.
Well, I feel like we've given Serena and
Science,
Alex a great chance to talk about what they're really excited about in terms of science. Is there science that you're looking forward to, Sergey, or something else?
Ну, в первую очередь, я, конечно, ожидаю выполнения всей научной программы, которая предназначена для меня. Очень много запланировано.
Completing the entire complement of all the science research experiments that are planned for me. There are quite a few experiments on the schedule.
Но, конечно, в первую очередь мне, как пилоту, хочется исполнять эксперименты, которые связаны с наблюдением за Землей. Это детская мечта.
Mostly, since I'm a pilot, I have a childhood dream, and I would like to perform a lot of science experiments that deal with Earth observations.
Также есть много экспериментов, связанных с внекорабельной деятельностью, которые также для меня просто фантастически интересны.
There are also a lot of experiments that are related to the EVA, and they're fantastic, and I am very interested in those.
Но в первую очередь меня, конечно, интересуют те эксперименты, которые направлены на дальнейшее развитие технологий по исследованию глубокого космоса.
But most of all, of interest to me are the experiments that target future deep space exploration technologies.
Потому что МКС может сейчас использоваться как отличная площадка для развития технологий, для дальнейшего их продвижения и развития человечества уже вдали от Земли.
Because ISS currently can be used as a base, as a platform for future research and enable the humanity to move deeper into space in the future.
Great. That sounds wonderful. All right. I think we've got another one back here.
Excuse me, Brian Krushan, JSC. For Dr. Auñón, I'm curious, as a practicing physician, if you could take us back to your time in medical school and residency, and now you're going to implement biomedical research on the space station. Was that the best training? Are there specific techniques you learned as you addressed patients that you'll employ on station, and will anything be different on station?
I think these guys hope so when I end up drawing their blood at some point on station. No, it's been the journey. Brian, thank you for the question. The journey's been very interesting. And when I picture myself up there now, performing these experiments, you know, I'm used to performing them on someone else, and now a lot of these are going to be on myself. So I'm really interested to look at the data. And, you know, especially in the immune realm, we talk about viruses. So, you know, everybody on this planet has viruses, and most of the time our body keeps those viruses at bay. They remain dormant within the body, or almost asleep. But sometimes under stressful circumstances or other situations, those viruses reactivate. And that affects everybody, right? Your grandma, your aunt, your dad, your mom, anybody who's had shingles or anything like that understands what that means. And so it's interesting that in spaceflight, we do see some of those viruses not reactivate clinically. I will say we see increased levels. So there's increased viral activity, meaning the virus has somehow awakened itself a little bit in our bodies. And, you know, why is that important? Well, working on the space station, there's several insults that occur to the body, like I mentioned, chronic low-level radiation, high levels of stress, day-night cycles. Everything is different from here on Earth. And so we're trying to figure out why our bodies react that way and how we could transition that to helping your mom, your dad, your brother, your sister on Earth against some of these viruses which we all suffer from. So it's, like I said, it's been a very interesting journey to finally make it to this point and picture drawing my own blood on orbit and storing those tubes away. The hard part is going to be that I'm going to want answers right then. And I know that's not going to happen. All that stuff is going to get stored in our big freezer up there, and then they'll be analyzed later on. But you could better believe I'm going to be knocking on your office to find out what all those numbers were once we get back.
And kind of along those lines, we have a question from Twitter that asks if you could talk a little bit about the quarantine that the crew goes through before they launch, and they also want to know if you have to be decontaminated at all before you get on the Soyuz.
I'm going to defer to Alex since he's been through the quarantine.
Yes, that's actually a very good question, because you do get decontaminated. On the day of your launch, you get an alcohol wipe down in the morning. And that was interesting. I mean, because I didn't expect that to happen, but they really give you a bottle, and then you have to wipe yourself down, because they want to keep the load of new microorganisms that you bring to the space station in any case. But they want to bring that as low down as possible, of course. But until that point, you were already 2 weeks in quarantine. So in Baikonur, we live in a quarantined estate where the crew lives, and all the trainers also live with us in quarantine, so they kind of suffer with us, so to speak, because they still train us in those 2 weeks. We still have classes on how to fly the Soyuz and briefings a lot on the latest state of the orbital data, because you only find out a few days before launch where space station is actually going to be and how the trajectory is going to be when you fly there. So we have a lot of work to do in the quarantine. You get your board documentation ready, the onboard, the flight data files. And it's actually kind of nice to be a little bit isolated in that time, because you can sort of have a quiet time getting that last work done. You want to sort of make peace with everything that you have on Earth, to leave that behind you, to focus on what's ahead. So I actually really enjoyed that time in Baikonur. You can see our families through the glass, so that's something new, of course. Like you see them right there, but yeah, you can only see them through the glass. But it's, for me, from my mindset, that was already part of the mission. So I just saw this as, okay, this is the first part of the mission, is still on the ground. But if you see it that way, it's not that bad actually at all.
Doesn't sound awful. All right, we're actually going to go now to the phone, and first of all, we're going to go, I think, over to the European Space Agency, where we have some reporters standing by to ask some questions of Alex and probably the rest of the crew.
Thank you, Brandy. Here's Isa Pio from European Astronaut Center in Cologne with some questions from European media to Alexander Gerst. First question is from Roscosmos of Bild Zeitung. Private space companies such as SpaceX have ambitious targets for a manned flight to Mars. Do you think these plans are realistic at all, and would you fly to Mars on one of these rockets?
Yeah, thanks for the question. I did indeed watch SpaceX launch, and it was certainly an impressive engineering achievement. Seeing those two boosters land right next to each other, I thought was an amazing feat. But let's not confuse that with a journey to Mars yet, because on such a journey, when we really want to fly to Mars, we don't only need a rocket, we need a spaceship, right, to fly there, with a life support system that's reliable. We need a lander, we need return capabilities. We need so much more than just a launcher. And until we have that, we cannot talk about the reliability of such a system, because it's just not there. And that brings me actually to what we do on the International Space Station, because we use that as a test bed for the further journey to the Moon and later to Mars. We develop new life support systems. We have a European one that we will fly on Space Station, the life support rack, to get life support systems more autonomous. We look at systems that work more autonomously than the ones we have currently on the International Space Stations, which are mostly controlled by ground. When we fly further out to Mars, we need to experience on how to have systems that can be self-controlled or controlled by us. We need so many more steps, and we're actually working there also on the spaceship. As you know, we are developing currently with NASA together the Orion spaceship. ESA is providing the service module, the propulsion module for that spaceship. So this is the spaceship that might fly to the Moon and Mars later on. So we're working on that. So It's actually exciting times right now. Also, the Deep Space Gateway is developing. It's an outpost, an orbital space station that circles the moon, is in an orbit around the moon, that is internationally being built right now. So we are actually working on those plans, and it's an exciting development right now to see which module comes from where, how the new Deep Space Gateway comes together. I'm really looking forward to seeing how that develops.
Next question is from Catherine Graneman of MACA. Are you looking forward to something in particular that you enjoyed during your last mission?
Is that for me as well? Right?
I think so.
Yeah.
Are you looking
forward? That's a good point. Yes, I think everybody who's flown to space wants to go back. That's what I heard from many of my colleagues, and that's how I feel. Being in space is such a special feeling. I think you can't even put it down to only one thing. It's not only the floating, it's not only the looking out at this beautiful planet, it's not only the perspective that we have, it's more knowing where we are. And at the beginning, before my first flight, I saw space as something very special. I thought this is a very special place to go to. And when I was up there, I actually learned that it was the opposite. The opposite is the case. Space is everywhere out there. The universe is gigantic. It's black and empty. Of course, there's quite a few interesting places to go to, like Moon and Mars, and we will go there. But most of it is empty. So the real special place, and that's what you realize in space, is actually our planet Earth. This is like the only real special place that we know in the universe. And seeing that from the outside, seeing that from a step back, made me realize that. And that was a very beautiful thought and a beautiful feeling. And it left me with the longing of coming back home to that planet. I didn't mind being in space for however months, that's fine, because I knew I could come back. And I saw this planet right in front of me every single day, and it was so beautiful. And that's the thought that I'm looking forward to most, to returning, is actually to being out there and looking at that planet, but not just like in a sense of just like a photo in front of me. It's more in the sense of feeling what this is, understanding what this is, a little blue ball of rock that's surrounding the sun once a year. It's a little bit like a spaceship, and yeah, we don't have another one. We don't have a planet B. And seeing that from the outside was overwhelming, and I'm actually looking forward to that as one of the things I like most.
Okay, a question for all of the crew from Christopher Maiden of Countdown Podcast. And the question is, imagine you would stay not 6 months, but 2 years on the ISS to simulate a mission to Mars. What do you think would be the most important things that you would have to change about the ISS in order to be able to do this?
I hope they get all our food up there. That would be the most important thing. I think certainly you'd have to allot for such a long time period. A lot of it is your mental mindset. You know, it's sort of part of that behavioral health care that goes on prior to flight, in flight, and post-flight. And what I mean by that is, you know, NASA and all the space agencies take very good care of our families. Certainly the months leading up to flight and then in flight, being able to communicate with them. And the interesting thing that I've learned, NASA utilizes a lot of analog environments to help train for spaceflight, and one of those is Antarctica. And I think probably one of the most isolated places you can be on this planet is Antarctica. And what I learned from that was how important it was for almost everybody on our team to be in contact with home, whether it meant phone calls or text messages, which are actually quite difficult from way out there. It's much easier on the space station. You can pretty much call any cell phone at any time, almost any time. And so I think just having that plan in place to make sure that you had good contact with your family and everything was being taken care of, which again, NASA does a great job of right now. But then almost you begin to think, when I returned from Antarctica, and it was only 2 months, the most memorable experience I had was landing in Christchurch, New Zealand, and the door to the aircraft opened and I smelt grass. And
That's
I
exactly the
realized,
same
oh
thing.
my goodness, the smell of the earth is incredible, incredible. I didn't realize how much I missed it and how absent it was in that environment and how important it was.
Yeah.
So could you somehow incorporate that? And we do grow plants, vegetables on the space station. We've been harvesting lettuce and all kinds of things, and I know that's going to continue. Psychologically, I think that's huge.
Yeah.
So those are some of the things I think about.
I absolutely agree. I mean, that's very well said. I remember that feeling as well after Antarctica, and also after my landing, when the hatch opens and you suddenly smell Earth. And it's amazing. Also, maybe to add from a technical point of view, it's you mentioned food, and it's a very good point because you can calculate how much food you would need to fly to Mars, and it's a lot, right? So it weighs a lot if we just use it and then throw it away. And so one of the things we were working on is to support life support systems, not only to reuse the atmosphere much better, but also to sort of reuse food the way we do it on Earth, right? So in order, in the end, to have to fly to less water, less food, and to get our spaceship a little bit smaller. That is something that we technically need to achieve before we go on that long journey, and we're working on it, but it's still a long ways to go. Like life support systems, you think it might just be one other system of a spaceship, but that's actually the one that's notoriously the hardest to build in a closed way. I mean, nobody has ever managed that, to build a completely closed life support system. There's been many tries, and they never worked. The only one that we know of is actually our planet Earth. So how to recreate that is going to be our challenge. We have, for example, for exactly that, the photobioreactor on board to try to find out how we can use biological processes for life support systems. And it's going to be interesting to find out how that turns out, how much further along that brings us with new life support systems.
Sergey, anything you would add?
Да, в моем понимании полеты на Марс будут связаны с автономностью этого предприятия, потому что корабль должен действительно быть в отрыве от средств связи. И, как уже сказал Алекс, необходимо искать новые пути получения как еды, так и воздуха, газов. Поэтому здесь немножко придется нам поменять вообще идеологию космических полетов.
As far as I understand, the space travel to Mars will have to be autonomous. There will be no comm with the ground, and as Alex said, we will have to find new ways to generate food, to generate air, water. So we will have to change the entire philosophy of space travel in order to accomplish that.
И также здесь выйдет на первое место, наверное, психологический аспект, который должны уже наши психологи будут подбирать экипажи таким образом, чтобы они в течение 2 лет могли спокойно пережить этот период, достичь нужных результатов и безопасно вернуться на Землю. И в этом отношении сейчас проводится масса экспериментов уже на МКС.
And I think one of the top priority items will be the psychological aspect. The psychologists should be working on designing the criteria, how they're going to select the crew members who are going to be able to live for 2 years on board of the spaceship traveling to Mars, accomplish the goals, and safely come back to Earth. And they're already performing some work on the ISS in order to prepare for that.
I think we had time for maybe one more question from ESA.
Yes, last question for Alexander Gerst. The question is from Thomas Zimmermann of the Holland-Holler Zeitung. What do you feel when flying in space over Germany, or perhaps over Baden-Württemberg or your home region?
Thanks. I think they didn't make you pronounce Kunstelsau, which would have been a little bit unfair, I guess. So that's the home region that I'm from, a little town that I grew up in. It's called Kunstelsau. It's in the southwest of Germany, in the state of Baden-Württemberg. And I hate to admit it, but it was actually one of the hardest places to find looking out the window. At first, I was not used to looking out and seeing the entire Europe visible underneath me in one photo, in one image. And I had difficulties finding places because, of course, the borders, they're not drawn in right on the ground. So you see this big green place with lots of forests, and I was like, okay, where does actually Germany end and the next country start? I don't even know. So the first place I tried to look for was Cologne because it was on the river of Rhine, and I knew that should be easy to find, right? And I never found it in the first 2 weeks, and then I actually had to look on Google Earth, I have to admit it, on the space station to see, to match like the images. And then I realized that I've looked in Switzerland the whole time. I did not estimate the distances correct, right? So that long, it was how it took me to find Cologne. And then afterwards, I was looking for Künstlersau. And that's even harder to find because it's on a smaller river, the Kocher River. And in the middle of the Hohenlohe Plain with lots of forests and fields, it took me quite a while. But when I found it, when I saw it, that was an amazing feeling because all of a sudden you see a place that you know really well, but you see it from a completely different perspective. And I was not completely prepared for that. That was an amazing moment. Also, it completely shifts how you see home in total. That's what I found. And it's a little bit like what Serena said before. If you're away from that place that you know that you grew up from, it doesn't matter if you're in Antarctica or if you're on the space station, when you come back, you see at this entire thing that you come back to as your home a little bit. So for us astronauts in space, we do see, after a while, we do stop seeing like our little hometown as the only home or like our home country as the only home. We do see Earth as our home. So if we come back, even though I land in Kazakhstan, a place where I have only been a few times before, it feels like home. But then if you have this special place that you know so well and see it from above, it even has a place in my heart that's even a little bit more dear, how to say. It's difficult to describe, but it's definitely something that everybody looks for from space. It's their hometown. And I'm looking forward to seeing these two guys, Sergey and Serena, looking down at theirs and see how quick they find theirs. People who live on the coast have an advantage. But for Sergey, I know it's not going to be so easy. He's from Chelyabinsk, which is at the southern tip of the Ural Mountains, so you might be lucky to find it quickly. It's a big town. So I'm looking forward to hearing what they say about that.
All right. Well, I think now we're going to take some questions from social media, and if there are any follow-ups here in the room, you can also raise your hand. But one that we have is from 9-year-old Gabriel in Germany, and he's asking, what is your favorite food that you've ordered for your stay in space?
Tortillas. I've just heard you can put anything in a tortilla, and I mean peanut butter, jelly, hamburger, Mexican, doesn't matter. Tortillas are ubiquitous up there, and I'm sure Alex will teach us new recipes once we get up there. But every video you see, someone is doing something with a tortilla, and they last a really long time. So that's what I think that's going to be one of my most favorite foods up there.
We'll definitely want to see some of your creations, so be sure and send them photos. Yeah.
And most important is fresh fruit, of course.
Makes sense.
Because we miss about earth, about fruit, and it will be very great support for us to have fresh oranges, maybe apple.
But that smells good, getting back to what y'all were saying earlier.
What I missed most in space was salad, but I couldn't get it. Now we actually managed to grow a little bit of salad in space, but that's only for scientific reasons, so it's really not something you can count on. And so I know exactly I will miss that most. I mean, I love salads. From the food that I've ordered, my favorite one is probably going to be cheese. So once in a while they send us a little bit of a block of Parmesan cheese, and that is good as gold up there.
All right. How about this one? Ian on Twitter wants to see if you can explain your patches, your crew patches, for him and the meaning behind them.
Yes, we can. You want to start with the Soyuz patch? Do we have it? Do we have one? No, we don't have it here. But you can describe it. What's on there?
Now we haven't patch of our Soyuz, just imagine picture. But on this symbol we have, of course, Earth, space, and 3 swans, white swans. They fly to the space. I think it's a good symbol of 3 members of crew, and its main main idea this is page.
Yes, great. What about your other ones?
The Expedition 57 patch was something that we designed because we were inspired by the early explorers, leaving out with their spaceships at their time, which were research vessels, research ships, leaving out to sail to the horizon and beyond. That's why we chose one of these research vessels as the central sign for our patch, seen from behind, seen from the perspective of the shore, and this vessel sails out into the unknown, beyond the horizons. And that always inspired me, because back then those people were the astronauts of their time, right? They went to long expeditions to Antarctica when it was dangerous, when it was expensive, when there were people saying, oh, that's not well spent money, it takes too long, and well, it's only ice out there and we cannot benefit from that, we should spend our money somewhere else, right? But these guys still left, and thanks to them, Antarctica is now full with research stations that generate the data that saves our understanding, saves our planet by fostering the understanding of climate data that we would otherwise not get if we didn't do the research there. So nowadays, nobody is doubting how important it is. We would have never discovered the ozone hole if it wasn't for research in Antarctica. Nobody's doubting that now, but of course, some of those people are out there talking about like this about spaceflight, and I think in 100 years from now, we will be in a very similar situation with the Moon and Mars as we are now with Antarctica. There will be research bases out there, and we will get understanding of our own environment, of our own Earth, that will literally save us one day. I mean, there's dangers out there in the universe that we need to understand. You could see us Earthlings as an island species living on a little island in a big black sea, right? And in order to survive, we have the duty to understand that sea around us and to know what's coming from out there. Otherwise, we might end up like the dinosaurs. And for that, we need all that research. We are explorers. And also, if you think back, how long humans are exploring their world, like hundreds of thousands of years we do that, and now since 50 years, and that's a blink of an eye in comparison with that time frame of our existence, since 50 years we have the ability to fly to space. So we are right at the beginning of space flight, and that space program itself, I'm not talking about the astronauts flying out there, but the space program itself resembles this ship leaving out to the unknown, flying over horizons to discover what's behind them. That goes in a geographical way, as well as in a scientific way, as well as in a personal way, right? For us, we are all going beyond our personal horizons, flying to space for the first time. We don't know, are we made for this? Is this too difficult for us? We have to encounter those horizons. We have to dare to walk up to them, and that is the symbol that we put behind that and that we see in that patch.
That's great, and a very unique patch too. It's really interesting looking. All right, I think we probably have time for just one more question, and I think we have one over here from Mark Carreau.
Mark Carreau, Aviation Week. What are the major training milestones before you get to Baikonur?
Before we get to Baikonur, I think certainly one of the biggest ones are our final exams that we have in Star City, Russia, to prove that we're ready to fly on the Soyuz safely as a crew. And so most of the time we are preparing for that. And that takes place over a couple of days there in Star City. Just prior, it's us and also the backup crew undergoes those exams prior to leaving for Baikonur. So right now in our training, we're doing we do special emergency sims for the US segment and the Russian segment of the International Space Station. Again, getting a lot of science briefings right now as the science starts to pan out and we find out what we'll be performing on orbit. We constantly get refreshers on station systems, which is important because we have to make sure that in the case of any sort of failure, knock on wood, that could come up on the station, we are ready for that. And then once we make that transition down to Russia, in a couple months or so, everything is focused on the Soyuz at that point.
All right. Well, I think that is just about all the time we have now, so we're going to wrap it up today. Thanks so much for joining us, and you can keep following what these guys are up to online at www.nasa.gov/station, and you can follow them on social media on Twitter at @AstroSerena and @Astro_Alex. I don't think Sergey has a Twitter account, but maybe they can talk him into one before they get up there. So that's it for today. Thanks so much, and have a great afternoon.